In this example, we will be looking at how ventilation can impact a burn. On the right column, we will see that the room is vented by an open door. On the left side, the room is unvented, where the door is closed. Because of this variable, we expect that the fires will be different. A fire starts when ignition occurs. From the infrared camera, we can see ignition occurring on the left side of the frame, as heat is transferred to the sofa. As the fire builds, we begin to see traces of soot, a product of combustion. Notice how soot is being carried up towards the ceiling by the hot gases in the thermal plume. Soot indicates that the fire has generated more fuel than it can burn. Over the next 30 seconds, you will see the fire work as a pump in both tests. The fire pulls in fresh air containing oxygen. The oxygen mixes with the hot fuel and burns. This adds energy and mass to the fire. Once these burning gases reach the ceiling and walls, they're trapped. A hot gas layer begins to form at the top, while cooler, oxygen-rich air stays near the bottom. As the fire pumps in oxygen, pressure inside the house grows. The hot gases try to expand and pump out exhaust. Notice the thick black smoke exiting the room, around the windows and doors. In the unvented fire, the room is filling with smoke. In this instance, the fire is running out of fresh air to pump into the room. In the vented fire, though, the open door is pumping in fresh air and providing an exhaust, or release, for the hot gases and thick black smoke. In the vented fire, we can see the phenomenon called pyrolysis. Notice the white vapors fall off the second sofa in the infrared view. Watch closely as the heat coming off the lamp to the left in the unvented room begins pyrolyzing. These gases are now fuel and will ignite or catch fire. Here we see the difference that ventilation makes for the outcome of these fires. In the unvented example, combustion ends because there is no more oxygen to feed the fire. The vented example, however, uses an unlimited supply of oxygen from the open door, allowing the fire to continue to burn. Ventilation is a phenomenon studied intensively in the fire lab. A better understanding of ventilation enables firefighters to make safer choices on a fire scene, as well as assist fire investigators when they analyze evidence and build their case.